bonding is similar to the lattice nature of ionic compounds. Atoms form covalent bonds to other atoms, which form bonds to other atoms, and so on, until what we have in effect is one giant molecule. Diamond is an example of this. It's a crystal of carbon atoms bonded to each other. That's why it's so hard and has such a high melting point. You would have to break the covalent bonds in order to do that, and they're incredibly strong. Graphite is only made of carbon as well, but it's not diamond, so it's an allotrope of carbon, made out of the same atoms, bonded together in a different way. Graphite consists of layers of carbons with 3 bonds each in a hexagonal structure. Where's the 4th bond though? Well, the spare delocalized electrons form special weak bonds between the layers, which means that it can conduct electricity because the electrons can move between the layers as well. And it also means the layers can slide over each other easily, which is why it's used in pencils. As a side note, metal alloys are stronger than pure metals. Having mixtures of metals means that we have different size atoms, and that disrupts the regular lattice so layers can't slide over each other as easily. Back to carbon allotropes, graphene is just a single layer of graphite. Fullerenes are 3D structures of carbon atoms. For example, Buckminster fullerene is a spherical football-like structure consisting of 60 carbon atoms each. Fullerenes that have a tube shape are called nanotubes. Just for triple real quick, nanoparticles is the term given to structures that are between 100 and 2,500 nanometers in size, whereas particles bigger than this are called coarse particles like dust. Surface to volume ratio is just 1 divided by the other. If the length of a side of a cube doubles, that means this ratio halves. As nanoparticles are tiny, this ratio is huge for them, which means that fewer could be needed to fulfill a purpose compared